Good morning, my YouTube viewers. It is Crystal here. I'm here this morning because I want to give you a code review. I couldn't do a code with me or a study with me because the file was too big. There was too much to do to the file, and because there was so much to do with the file, I decided to go ahead and work on it on my own and then make a code review. So this is the Spaceship Titanic, which is a spin-off from the Titanic dataset, but it had a lot of work that needed to be done to it. And so I did a lot of work on it yesterday. I worked on it all day long yesterday. So we'll go over to my submissions. I got a 74.164%, and the highest percentage was about 81%. So I only got about 7% less than the highest score. So that's not too bad. And so we'll go ahead and go over it. Come over here to Spaceship T, that's Spaceship Titanic. So now we've gone into the Kaggle Notebook. It says there was only one view. I don't know why there was only one view because I made it public. Yeah, it's public. But there was only one view anyway. So I guess not too many people were interested in looking at my notebook. But you can look at my notebook. So the first thing that we did was we read our problem statement. And as I said, this is a spin-off of the Titanic data set that's famous. It says, welcome to the year 2912, where your data science skills are needed to solve a cosmic mystery. We've received a transmission from 4 light years away, and things aren't looking good. The Spaceship Titanic was an interstellar passenger liner launched a month ago. With almost 13,000 passengers on board, the vessel set out on its maiden voyage, transporting immigrants from our solar system to 3 newly habitable exoplanets orbiting nearby stars. While rounding Alpha Centauri en route to its first destination, the Torre 55 Cancri, the unwary Spaceship Titanic collided with a space-time anomaly hidden within a dust cloud. Sadly, it met a similar fate as its namesake from 1,000 years before. Though the ship stayed intact, almost half the passengers were transported to an alternate dimension. To help rescue crews and retrieve lost passengers, you are challenged to predict which passengers were transported by the anomaly using records received from the spaceship's damaged computer system. Help save them and change history. So that's your problem statement. So the first thing that I did was I imported the libraries of NumPy, Pandas, Matplotlib, and Seaborn. So NumPy is a numerical Python library that allows you to carry out numerical computations. Pandas is a library that enables you to create data frames and manipulate and manage the data in those data frames. Matplotlib is a graphics library that enables you to plot the data points onto a graph so you can visualize your data. And Seaborn is a more high-level graphics library used in statistics, built on top of Matplotlib that does more sophisticated graphing than Matplotlib does. Excuse me. And then after we have imported the 4 main libraries, what we're going to do is we're going to load the files. So we import OS, which is a library that stands for operating system, and we go into the operating system and we look for all the files in the operating system, and we have sample, submission, train, and test. So now what we do is we read the files and we use pandas to read those files. So I've taken the 3 files that were in the operating system and I've converted them to data frames. So they're train, test, and submission. So you can see train, it is 8693 by 14 columns. You can see test, it's 4277 by 13 columns. And then you can see submission. This is what Kaggle wants to see when you submit your data or you submit your predictions. So the first thing we're going to do is we're going to analyze the train file. The first thing that we're going to do is we're going to look for any, sorry, they're making noise in the hallway. We're going to look for any null value, and you can see in the train file there's a lot of null values. And so what I decided to do in this particular competition question, which I've never done on a competition question before, is I have dropped the null values in the train file, and so I've named it train 1. So what it did was it reduced the values from over 8,000 to 6,606 rows, because that's what you have to do. You have to clean your data. And then I decided that instead of imputing the null values, because we don't know that information, I would just drop the null values. Now what I'm going to do is I'm going to analyze the target. Your target is your transported column, and I'm going to replace the true and false with 1 and 0. So you can see we've got all zeros and ones now. A 0 is false and a 1 is true. And so we can look on the, we analyze it using Seaborn disk plot file. And you can see the true and false, or the 1 and 0, are very similar in the number of ones and the number of zeros. So we have 3,327 ones and 3,279 zeros. So that means less people were transported to the alternate dimension than weren't. Now we look at the percentage. So you have 50% ones and close to 50% zeros. So it's very close. Now what I wanted to do is I wanted to make this graph. This is one of my favorite graphs with the Titanic website. I think it looks beautiful. So I wanted to put it in this program. And so what you have to do is, in order to get that graph to work, it has to be a float. The data that you use has to be a float. So I used it on age, food court, and VR deck, because it has to be a float. But I think it's a beautiful graph, and I wanted to put it in here. So now what we're going to do is we're going to drop the target. Target equals train 1 transported. Train 1 drop transported axis equals 1, in place equals 2. And so now you can see train 1, and you can see that the target has been dropped. So no more targets. So now what we're going to do is we're going to append the test setup to the train 1 set and form a large data set or data frame called combi. So this large data frame is 10,000 rows 883 by 13 columns. And now we're going to analyze COMBI. So COMBI tells you what kind of columns they are. So you've got some object columns and some float columns. Now you're going to describe COMBI. And what happens when you describe COMBI is it does a statistical analysis of all of the numerical columns. And if you do equals all, then that will give you all of the columns, whether they're numerical or not. But I decided just to stick with numericals. So now we check with null values, and you can see we've got quite a few null values still because there were null values in the train set and also null values in the test set. So I decided I had to impute the null values. So I put some code in to say not listed to impute the null values. And if it was an object column, then it said not listed. But that became a little bit problematic. So I had to go through and correct that while I was working on the program as well. So now you can see the COMBI data frame, and everywhere that there is a null value, it just says not listed. So now we check for null values again. We see we have no null values. And now what we're going to do is we're going to analyze all of our features. We analyze our home planet, and you can see there's more people on Earth, and then Europa, Mars, and not listed. We check for the counts to see how many people are on these 4 planets, including not listed. 87 were not listed. Then we check for the positions, and I put a pie chart in there just because I wanted to. And so you can see it says Earth, Europa, Mars, and not listed. So now what we have to do is we have to replace the strings with numbers, because whenever we are forming our predictions, the computer wants to see numbers. So we replace the strings with numbers. Now we're going to check cryo-sleep. And so again, because it said true and false, and these were Boolean values, and there was actually one that said not listed. So what I did was, if a value said not listed, I made it false. So there was this one column that said not listed, and so I printed off that one column using the iloc command. And then what I did was I replaced the true and false with ones and zeros. So you can see zeros and ones there. So now we've got a disk plot of cryo-sleep. So you can see less people had cryo-sleep than didn't. So now we did value count. So you can see 7,007 didn't get cryo-sleep, and 3876 did. We check our percentages. We converted this to an integer, and so now it's all integer zeros and ones. Now we check the destination. So we did a disk plot on destination. So we had our 3 planets and the one not listed. So here we did a value count, so you can see the 3 planets and the not listed. So the main planet was TRAPPIST 1E, and the next one was 55 Cancri E. The next one was PSO J318.5-22, and 92 were not listed. We checked the percentages, and now I've got a little pie chart for you to see what I've done. So now what we've had to do is we've had to take the string values and convert them to numbers so we can make a prediction on it. The next thing that we did was the age, and on the age what I did was I made some bins, and the bins were child, young adult, middle age, and pensioner. And so we created the bins, so you can see that. We did a disc plot on that, and so you can see most of them were young adults, and then you had children, then you had middle age, and then you had pensioners. And then we did an age.count, so you can see most of the people were young adults, followed by children, then middle aged, then pensioners. We did the percentages, and now I made a little pie chart, so you can look and see the percentage of people in the pie chart. And the next thing I did was I made the age group, and then I had to convert all of the strings to numbers because that's what the computer wants to see. And then I had to take the age group and convert it to an integer. We did the same thing with the VIP. Anything in the VIP that was not listed, we called it false. So we replaced the true and false with 1 and 0, so you can see that. Then we did a disc plot on the VIP. So we had most of the people were not VIPs, but we had a very small amount that were. So 10,647 were not VIPs and 236 were. Then we checked the percentage, and so almost 98% were VIPs and 2% were not VIPs and 2% were. And then what we did was we converted this true false to integers. Now we're checking room service, and I made a violin chart so you could see the room service. And then I looked at the maximum room service, which was 11,567. I took the room service and I converted it into bins with low, mid, high. You can see that. And then I did a disc plot on that. So most of the room service was low, but you had a little bit of high, and even a little bit of medium, and then even less high. So you can see low was 10,624, and mid was 253, and high was 6. We checked out our percentages, and then I gave you a little pie chart so you could see for yourself. And then what I did was I took the low, mid, high, and I converted it to numbers. The next thing we did was the food court. We did the food court in exactly the same way that we did the previous one. And what was the previous one? The previous one was room service. So we used the exact same methodology. We made a violin plot. We looked at the maximum value, which was 29,813. We used bins to make a low, mid, high. Most of them were low. Then we did a disc plot, and you can see most of them were low, a few mids, and then even less high. We looked to see the value counts, and then we looked at the percentages, and then we made a little pie plot so you could see that. And then we converted the low, mid, high to numbers. And then we used exactly the same methodology for shopping mall. So here's your violin chart for the shopping mall. The highest value was 12,253. Then we did bins. Then we converted the numbers into bins. We did a disc plot, so you can see most of them were low, a few mid, and even less high. We looked at the value counts. Then we looked at the percentages. And then I made you a little pie chart so you could see your low, mid, high. We converted the low, mid, highs to numbers because that's what the computer wants to see. Now we check the spa. I used the exact same methodology with the spa. The highest bid on the spa was 22,408. I used bins to convert it to low, mid, high. Then we've got a disc plot, so you can see most of them were low, a small amount were mid, and even less were high. We use value counts so you could see the values of the low, mid, high. We use percentages so you could see the percentages. And then I made a little pie chart so you could see the low, mid, high on a pie chart. And then I took the low, mid, high and I converted it to numbers. The next thing we have is the VR deck, which I use the exact same methodology. I've got a little violin plot so you can see that. The highest value was 22,272. Then what I did was I took the values and then I converted them to bins with low, mid, high. I've got a disc plot now so you can see most of them were low with a tiny amount of medium, and even less were high. So we use value count so you can see the numbers of the low, mid, high. Then I checked out the percentages so you can see the percentages. And then what I did was I made you a pie chart so you can see what they are in the pie chart. So I took the low, mid, high and I converted them to numbers. Now what I've done is I've assigned the features. So what I did was I checked combo to make sure that everything I wanted was either a float or an integer, and it was. And I assigned your features. The features that I decided to use were home planet, cryo sleep, destination, age group, room service group, food court group, shopping group, spa group, and VR group. Your Y is your target. Your X is your combi features to the length of train 1. Your X test is your combi features from train 1 length to the end. I did a little heat map on the features so you can see that. So it looks like on the heat map that most of them have a low correlation, but that's just what came up on the heat map. And now what I did was I split the data set up into training and validation, with 10% being the test size. And I selected the model, and so by this time I'd been working on it all day long and I was really tired, so I just decided to use logistic regression. So I used logistic regression, and you don't have to do any standardization on logistic regression. On another model you'd have to do standardization, so I may go back and standardize it and try a different model, but just for this one, because I've been working on it all day long and I was tired, I just used logic regression. Then I predicted on the validation set. We had a 74.4% on the validation set. I had my confusion matrix, so 36 were wrong on the zeros and 133 were wrong on the ones. Predicted on the test set. And so the thing is that this was a NumPy array, and so what I had to do was I got my predictions, and then I had to convert my predictions to a string, and then so I had to replace a 0 with a false and replace a 1 with a true. I prepared and submitted it. Submission transported equals predictions. Submission to CSV, submission CSV, index equals false. That means it didn't get an index. My submission equals PD read CSV submission, and my submission. And this is my submission. And so that is what I did to actually solve this problem. And then if you go back to the leaderboard, the highest score was 81%, so I scored 74%. So I scored like 7 below the highest score. So that wasn't too bad. And what I might do at some point is I might go through and standardize it, and then I might try another model like his gradient boosting regressor or an MLPC. But I think this is concluding my code review because I have to get up and go to work now. So I hope you got some meaningful out of the code review, and you can always look at the code on my Kaggle account, and I look forward to making more videos for you in the future.